Hello, welcome to the Willow's Physics channel. Today we're continuing with our previous topic on the black holes. To start off, let's get in touch with a term called no-hair theorem. What does the no-hair theorem mean? Surely it's not referring to someone who loses all his hairs for staying up late for deadlines. Here, the hair is a metaphor, which comes from the phrase that black holes have no hair by physicist John Ashford Wheeler. Hair means other information, and in this context of black holes, the no-hair theorem states that all black hole solutions from the general relativity can be completely characterized by only three external observable classical parameters, namely mass, electric charge, and angular momentum of the black holes. And all other information about black holes that the metaphor hair refers to falls into the event horizon of the black holes and becomes permanently inaccessible to external observers. Therefore, if we have two black holes of the same masses, same electrical charges, and same angular momentum, but these two black holes are made by different matters, we as observers outside of the event horizons are not able to distinguish the two black holes at all. To us, they are completely the same. However, the degree to which this no-hair theorem conjecture is true for the actual real black holes in the universe is still an unsolved problem in the current laws of modern physics. The black holes we're talking about so far are all assumed to be stationary. But in real life, black holes are rotating extremely fast. This is because the black holes are born from the supernova explosion, where before the explosion, the central star is rotating at a super fast speed. What's more, because of the conservation of angular momentum, as the radius of the central star becomes smaller due to the pull of gravity, the angular velocity of the central star is just going to increase even more. Therefore, the singularity rotates to become the ringularity. Now we're going to introduce the size of the black holes, which is determined by the radius of the event horizon, or the Schwarzschild radius. The Schwarzschild radius is given by the equation here, where m0 is the mass of the Sun. Therefore, if we look at the data from the Wikipedia, we can see that the radius of the black hole is indeed very, very small. Last but not least, we come to the ultimate question. Will black holes ever die? The answer is yes. Black holes will die, but very, very, very slowly. A famous physicist Hawking has predicted in 1974 that black holes are not entirely black, but emit small amounts of thermal radiation at a calculated temperature. This effect has become known as the Hawking radiation. If this theory is correct, then black holes are expected to shrink and evaporate over time as they lose mass by the emission of photons and other particles. By mathematical calculation, it will take about 10 to the power of 64 years for a solar mass black hole to die. In case you need a gauge of the magnitude of this period, the age of Earth right now is only about 4.5 times 10 to the power of 9 years. Therefore, it takes super long for one black hole to die. That's all for the series of videos on the black hole. If you find this video interesting, do hit the like button, leave a comment below, or subscribe to my channel. If you find any other interesting topics you want to learn, feel free to leave a comment below as well. See you in the next video.